Welcome to Engineering on the Edge, where we delve into stories and insights from those tackling the most challenging geotechnical projects. Before we begin, if you're passionate about geotechnical engineering, innovative construction solutions, and the complexities of building in difficult terrain, hit that subscribe button. Stay updated with the expert interviews and real-world engineering stories. Today, we're joined by Patrick Thomas, an engineering geologist at Access Limited Construction. Patrick brings a wealth of experience in geotechnical investigations for construction in challenging environments. Patrick, welcome to the show.
All right, Michael, thanks for having me.
You're more than welcome. So, path to geotechnical engineering. So I wonder if you could just tell us essentially your journey into geotechnical engineering.
Sure. I grew up in the engineering construction field. My father, grandfather, great grandfather were all engineering contractors. So I grew up in the construction field itself. And then when I got into geology, it made sense for me to get back into the construction and geotechnical engineering, since they go hand in hand. And I had the construction experience, and I was able to bring that experience to the engineering field, and had the insight, contractor's insight, and it made sense to connect the two and take it from there. And so I got into geotechnical engineering as a consultant. Spent most of my time in that field as a field geologist, doing quality control and observing deep foundation excavations and quality control for the ongoing construction.
Excellent. So what kind of key experiences shaped your career to date?
I think starting out as a laborer, working in the field and working, my first job was holding the hose when we were mix and fill when I was probably 14, and having that experience and working in that field for off and on throughout summers and breaks really gave me firsthand experience into how things should be done and the correct way to do things from the construction side. And so once I got into the quality control side, I already had the knowledge of how to do it right, and I think it benefited me greatly.
Yeah, it's great to, I suppose it's almost done from the ground up, no pun intended there. Because some people, they'll kind of come straight out of university or college and then want to go straight into maybe a consultancy. Some people don't even want to go on site too much. They just want to do the more kind of academic or office-based activities. But it always helps to be on site, see the sharp edge essentially of what's going on, the implications of striping your pencil through something, rearranging that sort of thing. So what if we can kind of just chat about tackling challenging terrains? Do you have any kind of projects involving steep slopes, unstable soils, and remote locations that we can discuss?
I have a lot of steep slope and unstable slope conditions. I worked for a geotech in LA for almost 10 years, and Los Angeles is known for having a lot of steep, unstable hillsides and a lot of wealthy people that want to live on those hillsides, which requires very complex foundations and shoring just to build some of these foundations. We're very seismically active here. It's the perfect combination of steep slopes, seismicity, and people that want to live in the hills. So my first major project as a consultant was a large landslide that we removed in the Pacific Palisades. Consisted of about 150 large diameter piles, and I forgot how many vertical feet of shoring. But in order to remove this deep landslide, we worked our way from the top down. It was the first major project I did, and I kind of got thrown into it, and it was a sink or swim situation. And I guess I swam because I'm still here. And that was in 2017. And it really opened my eyes to much larger scale of construction than I'd been accustomed to. But as you scale up, it's still the same. It's just a bigger pieces of equipment and deeper foundations and larger excavations. But the personality of contractors is still there. And fortunately, I'm well versed in that. My dad's a grumpy contractor, and I I learned a lot from him, and I was able to bring that experience to that project, which was difficult. It was a lot of difficult aspects of that project. There was, as I was saying, a landslide that had failed in the 60s and had sat untouched until 2007 or probably 2014. The project started, and then my phase started in 2017, and it was a great learning experience.
So that, I mean, we actually met there, didn't we? We met in El Segundo and had some food at a Thai restaurant together and kind of discussed some of your earlier projects. Just getting on to some of the kind of techniques and technologies, what have you kind of been exposed to during your 10 years along this sector?
As far as technologies, a lot of deep foundations, large diameter piles, tiebacks, soil nails for slope stabilization, a wide array of technologies that are utilized to bring these sites into engineering conformance and bring them up to the proper factor of safety. Um, a lot of going down holes, being lowered into deep excavations and checking to see where the bedrock was, and it's always an experience to get lowered in a basket 40 feet in the ground and look up, and all you can see is what looks like the sun, and it's just the ground above you, and you're deep in the ground, and it's kind of ironic that as a geologist you're allowed to get lowered into a hole where no one else can go, but I guess I was qualified to say, and still am, that no, I won't go in that hole. It doesn't look stable, or yes, I'll go in that hole, and it's it's a hell of a learning experience, and it's a lot warmer and sweatier down in those holes than you expect.
Yeah, that's something else we discussed, wasn't it? Because I think it's slightly different here in the UK. I mean, I'm not sure what the diameter of that kind of hole was, but you're generally not in terms of kind of trial pits, but they're not kind of 1.2 wide anyway. So what was the kind of diameter of that you're referring to?
Typically, they're 24-inch diameter. The biggest diameter I think I've gone down was uh, 30, 36-inch, so 3-foot hole.
Okay, that's still quite tight though.
Yeah, the tighter the hole, the better, because you can kind of lean against the side and stabilize yourself, because you're dangling on a cable, and so you're kind of just swaying in the hole. And if it's too big, it's you're trying to pick at the side of the hole to figure out where you are in the section. And those narrower holes are actually nicer, and they seem more stable.
They seem more stable. Have you ever had a kind of close shave, a narrow escape, or heard of anyone who has?
I've gone down a couple holes that I thought I should not be down this hole, and got pulled out of there real quick. They were just it looked good until we got to a point, and then got below the contact of the fill and the bedrock, and the bedrock was really trashed and crumbly and just nested rock, and I got out of that hole really quick.
Yeah, I bet you did.
Struggling to find top geotechnical and geoenvironmental talent? You could use a generalist recruiter, or you could use a specialist. At Geo Expert Search, we place experts where they belong. Across the UK, USA, Australia, and New Zealand. No highways, no bridges, no structures. Just geotechnical and geoenvironmental. Now and forever. Geo Expert Search. Finding the right people for the right roles with no wasted time. Visit geoexpertsearch.com to learn more.
So do you have any kind of case studies or past experiences highlighting successful outcomes within the kind of going back to the techniques and technologies?
Yeah, I feel like every project that I worked on was its own case study. Because the way it works, an engineering report is provided to begin with. We do our initial we would do our initial investigations, and then I would be on the construction aspect, and so I would get to see the real world, the application of what was engineered and designed, and then we were putting it into play. And so I feel like each project I did was a case study, because we would do our borings and our test pits, and you would know where rock is in one position, in one spot on the project, but you may get to another point on the project where it was difficult to explore, but there's still foundations that are going in there, and you're excavating for foundations and trying to find the right bearing material. And sometimes it's quite difficult if it's 20 feet of overburden on top of the bearing material. And just it took time to get more comfortable with recognizing the rock when it's coming out in spoils. Sometimes it's just powdered up, but over time, in years, I worked in the same geography, and so you get familiar with the geology and the color of the rock and what to expect and what you should be seeing there. And the record keeping in Los Angeles is really thorough. So you have a lot of historical reports dating back to however long they've been keeping records. Some of the records go back into the 20s, 30s, but pretty much anything pre 1964, the modern grading code in LA is deemed not really usable, but you can justify if you can take samples and quantify that the work that was performed then is still feasible and usable. But I've had projects that they were certified fill pads, but it was like a 50,000 yard removal recompaction. And as we removed all this dirt that had been compacted in the 60s, there was so much trash buried that there was good reason why the house that was there settled and the walls failed. And we did the right thing by removing and recompacting and recertifying the fill.
Yeah, sometimes it can be difficult when you're working in field until you see some kind of trash or wood or plastic or whatever it may be, and you go, okay, everything above this point then is actually just kind of man-made ground, essentially. So, in terms of your experience in multidisciplinary teams, what would you say the role of collaboration you've experienced in complex projects? How's that assisted?
The it's highly necessary for us all, be it consultants, contractors, architects, engineers, geologists. It's necessary that we all work together. I think it's sometimes thought that we're at opposing ends, from the consultant to the contractor side, but we're all doing it for the success of the project, and so that it's highly necessary that we all work together, and like no one's out to get anybody. We're all trying to build this thing properly, and so it's key that there's clear communication and a good relationship between the contractors and, say, myself in the field. I'm not trying to make their life more difficult. I'm just trying to verify and protect my client, saying that we're building this right. This is going to last your lifetime. You're spending a lot of money constructing this, and so we want to make sure it's done right. And sometimes things are bigger and need to be bigger and deeper than what was anticipated, and nobody likes that because it ends up costing more money. But it's for the longevity of the project and the integrity of it. It's necessary that the contractors and the consultants work well together.
Definitely. It helps when you're kind of working together. Well, that's the kind of, intent at the start rather than everyone kind of only looking out for themselves, which can happen, I suppose, when things go wrong. Then people kind of scuttle back and say, right, well, what's our take and who's responsible for certain things, which kind of makes sense to a degree. So, in terms of the communication between the geologist, engineers, and construction teams, what would you say actually makes for good communication?
I think just being forthright and honest. If something is deeper than it was anticipated, communicate it right away to all teams that are involved, and take things head on and not try to avoid those conversations, because it's inevitable that it's going to come up. And I like to sleep well at night and know that something is done correctly. And it I initially would struggle with those communications because I felt like, oh no, this is going to add so much percentage to this project, but at the end of the day, it's what we're there for, is to ensure that things are built properly.
Definitely. I think it's all too easy, especially when someone's starting out, to be scared to communicate with contractors, because sometimes they can be, I suppose, potentially overly forthright in some instances, which if you have a kind of fresh, new, timid geologist, depending on personality, then it can be quite hard to get round to that. So in terms of your lessons learned from working within interdisciplinary teams, what would you say the kind of top few of them are?
I think communicate and ask questions too. Talk to the contractors about what you think the best way to do something is as well. If there's people that have been doing it for years, and they may not be um, an engineer or a geologist, but they're still professionals, and they know how things can be achieved and what it takes to do something. And a lot of these guys have drilled more holes than the geologists have seen in their lifetime. And so if you have a good relationship with those contractors, you can communicate and brainstorm together on how things can be achieved and what is anticipated. And over time, you end up working with the same contractors over and over in different projects, and you end up developing that relationship and maintaining that level of communication, and a trust gets built too. And once that trust is there, it's priceless, because you know that you can count on them doing the right thing, and they also trust your judgment, and that you are giving them good recommendations as well.
So if you think back to kind of most memorable project challenges, how did you solve them? What's an example of that?
Oh, each one was a little different, but just being mindful and aware of what's going on while the project's being built, and also anticipation of what is what you're going to expect to see. And if you don't see that, then that kind of raises a red flag of, oh, okay, something's a little off here. Like there's a lot of west facing hillsides in Los Angeles in the Santa Monica Slate that they shattered in the Northridge earthquake, all these ridges. And so you would always anticipate on these west facing slopes that the rock would be just really jumbled. And so anticipating that there are going to be some nasty holes, that they may be supposed to be 30-inch diameter, and they end up opening up to 42 inches just because it's bad crumbly rock. And just anticipating what you're going to see, and do research before. I mean, the research is reading the geotechnical report that my company would provide, and also going through the previous reports if they existed for a site, and seeing what other consultants saw, and in a means of anticipating what is it expected to find on the project.
So you say it's important to be kind of adaptable then, because if you're thinking it's 30 and then it opens up to 42, I mean, how do you problem solve for that? How do you remain adaptable?
I mean, you kind of hope for the best, and then if that hole starts caving, you gotta recommend casing or something to keep the project safe too. Because a lot of times, if a hole starts opening up, you've got a drill rig sitting right on the edge of the hole on a hillside. You don't want to. You Safety's number one. I don't want to ever see anyone get hurt on a project. Integrity of the project's number two, but the first priority, I think, is safety. And so just that goes back to the communication with the contractor of saying, hey, this is getting dangerous. I don't recommend that we continue doing this in this way. Let's stop and figure out a different solution. Just making sure that the project's safe and stable.
Definitely getting everyone home at the end of the evening.
Yeah, that's the most important thing at the end of the day.
Definitely. So what advice, looking back at your 10 years of experience, do you have for aspiring geotechnical engineers?
I think just keep an open mind, and remember that all trades are in this together. We're not enemies. it takes a team of people to accomplish these projects, and yeah, keep an open mind and be aware that things change at a moment's notice. It's rarely what you expect to see, and you're gonna experience a wide variety of personalities that you're gonna have to deal with, and keep a level head, keep a cool head. It's easy to get heated. It doesn't benefit anybody when tempers rise, and just keep it cool, even head. And if you don't know something, ask. I mean, call your boss and ask for their advice, or like I was saying, communicate with the contractors you trust, and see what they think. And over time, you you gain trust in yourself too, and your own insight, and um, your expertise.
So you mentioned there about kind of personalities, different personalities. How do you kind of navigate around that if you have kind of different teams, contractors, consultants? How do you manage that? Because some people just don't really get on. How do you manage problems like that come up?
Oh, it's a case by case basis, but I think for me, growing up in construction and working with contractors, I had that experience with those personalities from my whole life, and that benefited me greatly. But just it goes back to keeping a cool head. I mean, I was guilty of getting heated at times, and it didn't benefit anybody. It just you'd have people that are upset, and that doesn't help the flow of a project. And if someone's not doing something to your recommendations or to the recommendations of the engineering report, just it's not approvable, and you find a different way to do it and make sure it's done right. And I think the biggest thing I learned for that is, and with dealing different personalities, is keeping a cool, level head, and maintaining maintaining a center of of uh, of coolness. I guess I can't think of a better term at the moment. Just maintaining a level head, and it's that benefited me greatly, because it's much easier to communicate when everybody's not their tempers aren't rising and people are getting heated.
So, with your experience, if you could kind of go back from what you know now to when you very first started, what kind of key piece of advice would you give young Patrick?
Keep a cool head, and just communicate when initially, just like right away when something seems off. Don't internally try to find a different solution to keep doing what isn't working, because you're afraid that your company did something wrong or the exploration was wrong. It just communicate right away, and it's easier to nip something in the bud before it expands into a bigger issue. If you see a problem right away, communicate it to the general contractor, the architect, the engineer, the geotech. Just communicate that something is different than anticipated. And it also goes back to, if you're looking at a set of plans and you're going to go build something, and you see that it's not going to work in the field, that's another. You pick up the phone and you call the structural engineer and explain the situation, because being the one in the field, and the eyes on the ground and the boots on the ground, things are different in the field versus a set of plans. And all those consultants are doing the best of their ability to design something that is buildable, but there are times where things get missed, and things don't work what are not going to work out as designed, and you have to come up with a different solution. And it just goes back to communication, and not fretting the the blowback of the communication. It is what it is at the end of the day. It's you can't change the reality of the situation.
You have to deal with the hand you've been dealt, I suppose. So,
Yeah.
Patrick, thank you very much for sharing your experience and insights. Your journey underscores the importance of innovation, collaboration, and resilience, of course, which we mentioned a few times there in geotechnical engineering. For our viewers and listeners, if you found today's topics and discussion interesting, give us a thumbs up, share your thoughts, comments. Do not forget to subscribe. for more expert insights into the world of engineering. Patrick, thank you very much for coming on the show.
Thank you, Michael. Thanks for having me.